Welcome everyone. So this is the first part of this video. This is the first lesson in which we are going to talk about introduction to C++. And for this part of the video, we have the audiences are anyone who just wants to learn C++, and this course is meant for beginners. If you are a school or college student, you can absolutely take this course and enhance your knowledge. So for this module or for this video, I want to set some objectives that by the end of this video, you will be able to display some text onto the screen. You will gain knowledge about what are the functions, what are namespaces, how to create and use them. You will get some knowledge about what are preprocessors, how to use them, and then you will also write some code to practice the above skills. So the approach that I will be taking in this course is we will be writing first program that is printing your name. This will tell you the basic skeleton of a C++ program. Then we will continue to writing a simple file menu of a text editor. And for now this file menu will not be functional. It is going to be just printing some text onto the screen. But we will learn great things using this example. We will learn about the interface, we will learn about the preprocessors or namespaces, especially in this case. Then we will learn about how to organize your code in multiple files, and after that we will summarize everything what we have learned or what we have discussed in this video. So let's start by our first program, that is printing hello Zen onto the screen or printing your name onto the screen. For that I want to start from the scratch, so let's go ahead and open a text editor of your choice and you can just click create a new file. For this I'm going to name my file intro.cpp. So .cpp is the extension of a C++ program file. So any file that ends with this .cpp extension is a C++ program file. And the one another common extension that you will find is .cc. So .cc was called as C with classes. When the C started in its early days, then it was named as C with classes. So the extension that was used was .cc, which means C with classes. So these are two extensions that you can find onto the internet or in many of the files. So now I want to start by writing a basic skeleton of a C++ program. So the basic skeleton of a C++ program is, first of all, you need to include a preprocessor statement. So we included a library called as IOStream. This library is called as input output stream. This library helps you to print some text onto the screen to get some input from the user, and it just basically helps you with input and output instructions. Next, every program needs to have a main function. So we created a main function, and the main function should always return some type of integral values. So in our case, I just mark it as int. So this main function is going to return some integer value. So let's return some integer value of 0 from the main function. Now we are going to talk about why this function should return an integer value and why in most of the cases on other websites and several books you will find this main function written as void main, and then there is no return statement required at all. But we will be talking why that's not the correct way to implement the main function in some time, okay? But for now, let's continue about printing our name onto the screen. So this is the complete simple skeleton of a C++ program. Now any statement that we need to write will be written inside of this main function. So the first of all, I want to start with comments. So comments help you document your code. They helps you write what the code is about. what a program is going to do, what a specific statement is going to do in your program. So these comments are not processed by the compiler. Compiler just goes about deleting them all. Compiler does not pay any attention to them. So let's say I am printing my name, and to print my name I can use a simple function called as put_s, which simply says put string. S stands for string in this case. So whenever I want to put some kind of string onto the screen, I can use the put_s function in my case. So I can say hello Zen, and then every C++ statements need to end with a semicolon, so I need to place a semicolon at the end. So this is all that I need to do in order for me to print my name onto the screen. But the program is not going to run on itself. It is going, first we need to compile the program, then we need to execute the program. So for compiling the program, we need to have some kind of compiler. In my case, I have already installed the G++ compiler on this machine, so I will be using that G++ compiler. Now, how we can use that is you can open your command prompt, and then let's browse the directory where we have all these files. So I have a CPP folder in my case, and this CPP file folder holds all of my C++ files that we will be talking about in our example or in this course. Okay, so we have the intro.cpp file over here. The intro.cpp file is the main file that we are working currently in, and I'm going to get rid of all other files for now so that we can just focus on one file, that is intro.cpp. If I want to open a command prompt over here, I can go to this address bar, clean everything onto here, and then I'm going to type cmd and press the enter keyword. So enter key. Okay, so this is going to open a command prompt for me, and now inside of the command prompt I can issue the command g++ followed by the name of the file that I want to compile. So in our case we have intro.cpp file that we want to compile. So let's say intro.cpp, and I will hit the enter key. So the compilation will finish, and it is going to create an executable file for us, that is a.exe. Now we can double click on the file and it is going to run and exit itself. But the program will immediately print something onto the screen and exit itself. That is not the case that we want in our case. So another way that we can prevent this kind of thing is we can execute the command, or we can execute the program inside of a terminal, so that even when the program runs and exits itself, the output remains on this command prompt. So for that we need to just enter the name of the file followed by .exe, and in our case we see that hello Zen is successfully printed onto the screen. Now another thing that you might consider is that I do not want this program to run every time inside of a terminal. I just want to make this program such executable that whenever I click on it, and it should print the hello world, and then it should wait for some time for me to see the output of the program, and then after I see the output of the program, then it should exit itself. For that kind of behavior, we can look at the C++, or we can look at the command prompts commands. For now, I can type the cls command to clear my screen, and then I can type the command called as pause. This pause is a Windows command prompt command. Okay, so the pause command is built into the Windows, and you can execute it on any kind of terminal or command prompt. Okay, let's enter. Let's press the enter key, and we see press any key to continue. So for now, the terminal is completely paused for some moment. It is asking us to press any key, and whenever we press any key, it continue its execution. So we want some type of this type of execution. So we need to figure out how we can execute commands inside of the command prompt from our C++ program. So we need to somehow figure out how to execute system commands using C++. Okay, so that is our goal. We want to do something that fulfills our condition. In our case, we want to execute system commands using C++. So C++ also provides us with a function called as system that takes the commands as an argument, and it just execute that command onto the command prompt. So for that we use the system function, and the system function is going to take the string, or inside of the string we need to pass what is the command that we need to execute onto that command prompt. So I'm going to type pause command over here, and then I'm going to put a semicolon at the end. So the line number 9, the system function will allow us to execute any command that we specify in this command prompt. So we specified the command called as pause, and you already saw that the pause command is available for the Windows inside of this command prompt. So whenever we execute the pause, you can see the command prompt just sits and waits for us to press any key, and then after we press the key, it continues its execution. That is what we are doing over here. We want the program to stop for a moment, ask some type of input from us, and then we want it to exit. Now, when we have done that, if we execute the a.exe now, there will be immediately the program will run and exit itself. That is because we haven't compiled the program again. So every time we make some kind of change to our program, we need to compile it again. So let's compile it again. G++ intro.cpp. So again we got an a.exe file written. So now whenever I open my folder that's contain this a.exe and I double click on it, the program is going to print hello Zenth onto the screen, and then it is going to ask me press any key to continue. So it is going to pause its execution at that state. So I want to say that this is the way we can create some programs that just waits, prints something, it displays the results, and then waits for the user input. And this helps us just to create some beautiful programs in C++. Okay. Now I want to proceed further, and I want to take this approach a little bit more, I want to take this approach to a next level. Okay. So how would I go about to that? Now the another thing to figure out is about these functions. So we have already used the function called as main, and as I said, it just returns an integer value. So integers values are positive numbers without decimal points in case of programming. So in programming we have 0, 1, and these are to a fixed limit. The numbers are not infinite. We have fixed number of numbers, we have a limit to these numbers, and that is because we have a limited memory inside of computer. That is why we have fixed number of a fixed range of integers in our case. Okay, so now let's continue further, and I want to talk about our second program that we want to write is program that we want to implement as, let's say, a text editor. And this text editor is going to teach us about functions. So in our case, we are going to implement a simple file menu of a text editor. So the file menu has a lot of buttons inside of it. Let's say if I run the notepad and I display you this file menu, then it has several buttons inside of it: new window, open, save as. So we are going to just create all these buttons, and we want to just simply do something with them. So we have this type of functionality. So we have these buttons inside of the file menu, and each button is responsible for doing some kind of task. So the entire program, that is Notepad, is divided into several tasks, such as, for example, undo is a task which just gets back what the word or keyword that you have written or deleted. It just restores you back to that state. And cut is also a task, or you can say it a function of Notepad. Copy is also a task or a function. Similarly, we have a lot of other tasks and functions in our case. So our entire software is divided into several tasks, small tasks. And we have, for all of these tasks, we have, let's say, new, save, open, export, print, and exit. All these are tasks. So for writing a task or for grouping a bunch of statements and labeling them, we have functions. So what are functions? Functions are just group of statements which are provided some kind of a label. So in our case, as we saw that we have a main function, the main function has all these statements which is put as which is prints something onto the screen, and the pause statement which pauses the execution of a program. So these are the statements, and we provided these statements a label called as main. Similarly, we can also create a function called as add. If I have an add function, let's say it just returns integer type of values, and for now let's say it returns 5 or 4. If I want to print that value onto the screen, I can simply say printf. Printf is another function that we have to display something onto the screen. So we will be talking a lot of ways to display text onto the screen and difference between those ways. So printf is another way to print something onto the screen. Let's say I call the add function and it returns an integer value. So the syntax to print using printf is, first of all, you need to have a string, and inside of a string you need to provide a placeholder on the string that you want to print. In our case, let's say I have a addition is, and then I want to print the result of the addition. So for that I have a integer value. So for representing an integer value inside of a string, and you specifically inside of print a function, we have percentage d. Percentage d stands for integer values, okay, for any values that are without decimal points. So percentage d is used for those values. So you can just print a backslash n at the end to print a new line, and then a comma, and then you pass the value with which you want to replace this percentage d. Let's say if I want to replace this percentage d with a 10, then I can pass the value 10 over here. Whereas if I in the actual compilation, when the compiler is going to compile this program and it is going to generate some kind of output, this percentage d will be replaced with 10 in our case. So if we have any value passed after the comma, that will be replaced with this percentage d, that value will appear in place of this percentage d. So in our case, we want to call the add function, and let's put a semicolon at the end. Now let's compile and run the program once again. Let's say a.exe, and you can see addition is displayed as 4. You can press any key to continue the execution of a program. That's all. So now let's say we want to make this function such that it should accept some kind of arguments. It takes the number, it takes two numbers that we want to add, and then it returns the sum of those numbers. So you can pass those as an argument to the function. Arguments are always provided between these opening and closing round brackets. So for that we need to specify the type of value that we want to accept. So in our case, we want to accept an integer value, then the name of the value that we want to accept. Let's say I want to name the first value as number 1. Then I want to accept another number. I want to name it number 2. So in this case, I can return the num1 plus num2. So that is all our add function is going to do. It is going to return the sum of two numbers. and we will provide those two values over whenever we invoke this add function or whenever we call this add function. So let's say I want the sum of 10 and 20. So I pass the add function a sum of 10 and 20. I go ahead and compile the program. I run the program and I see that sum of 10 and 20 is 30, and then we can execute, press the enter key to continue the execution of the program. And that's all the functions are about. Functions are about a specific task. So in our case, the task was to add two numbers. So we wrote the statements which added two numbers, that is number plus number 2 is the sum of two numbers that we want to add, and then we returned it out of the function. So this is how the functions work. Functions are just the tasks that need to be performed, and they contains a bunch of or group of statements inside of them. Now, functions prevents duplication of the code. Let's say you want to, in our case, we created an add function. So you can create lots of other functions, whatever kind of functions you want. Functions could receive different type of values and they can also return different type of values. So it reduces the duplication of the code. So whenever we need to add two numbers, we can just simply call that function and it will return us the result. You can similarly create the function for adding three values, for adding 5 values, 10 values, 20, and so on. So this will help us organize our code a little bit better. It makes the code cleaner. And next thing that you have to pay most attention to it, that you should always create a function for one task. Or in other words, a function should not do multiple things. So in our case, where is that? Yes. In our case, we have an add function which just simply does the addition. It does not do anything else than that. Whereas in our case, if we were to print something onto the screen, let's say this, you are adding two numbers. So let's say we want to print this text onto the screen. So now this is not going to be a good approach to doing something like that. Why is that the case? Should a function should always have one statement? No, a function can have multiple statements inside of it. For example, in our main function, we are just printing something, we are doing something else. So if this put s is required for you, then you should put this definitely. But in our case, we do not require this printing something onto the screen. It will handled by our other function, which is main function. The main function is going to call this printf function. The printf function is going to call this add function. It is going to get the result out of this add function, and then it is going to print the output onto the screen. So that is what the execution of the program would look like. And let's say if you want to have some type of, let's say, division, let's say integer division is equal to num1 divided by num2. Now this would be totally irrelevant for the add function to do a division. We do not want some kind of division to be done over here. So we should never create a function that does two tasks. So in this case, the add function does the division and the addition. And for that we are just increasing the complexity of a function. This would just disturb the code maintenance issue. This would bring in a code maintenance issue. The code will not be maintainable anymore if you do multiple tasks inside of a function. So it is always better to do one task inside of a function. So now I want to continue and I want to develop the text editor that we want, that we said that we will be doing inside of this course or inside of this video. So the first thing to understand is the syntax of a function. So syntax of a function is just pretty simple. First of all, you need to put the return value. What is the kind of value that the function will return? So in our case, we specified that main function is going to return an integer type of value. So we did that. We put the integer in front of the name of the function. Then we need to specify the name of the function. So in our case, the main function was fixed. It was to be named main. If you name it something else, the program is not going to work. Every C++ program requires that it should have at least one main function. Then there are arguments to the function that you need to pass, and void simply means there will be no arguments passed to the function, or the function does not accept any arguments. So that is the meaning of this void over here. So we can also add void to our main function if we want. Over here we can specify the void keyword, and it is going to have no impact on our code. The code is going to still work. Now I want to code the text editor. So our text editor is going to have functions such as file, file menu. Okay, so functions such as open, save, and then we have export, new, and exit. Let's say we have all those functions, and we can also look them. New, open, save, export, exit. Okay, so new, open, save, export, exit. Okay, we have all of that. Okay. So we need to create the functions for each of these. So let's say we have void. Void simply means the function is not going to return anything out of it. It is just going to do something, and then it is going to exit itself. And the function we are going to create is a new function. Now the new function will not take any argument in our case, so we will be doing a void inside of it. And now I want to show you another way that you can use to print something onto the screen. So another way we have is std : cout. So this is the another way, or C++ way, to print something onto the screen. std : cout. Then we have stream insertion operator, that is two less than symbols, and then the text we want to print onto the screen. So we want to print this is creating new file. So let's say, and then we have \n to print a new line at the end. Now there is one issue with this function. The function is named as new, and new is a reserved keyword of C++. So C++ does not allow you to name the functions which have reserved keywords. So if you type the new and you see that it is a C++ keyword. So C++ has statements similar to, let's say you have this return keyword. You cannot use the return as the name of the function. Similarly, you cannot use integer as the name of any function. So these are few words that are fixed by C++ which you cannot use. So we need to name a function a little bit. We need to name a function something else than new. So in our case, we can name it as file underscore new, or you can call it as new file, which would make much more sense. New file, okay? And this is just a simple function which is going to create new file onto the screen. So now I'm going to do is, inside of the main function, let's say we are implementing our text editor and we want to create a new file. So we would simply call the new underscore file function to create a new file. If I go about compiling and running this program, let's compile it. Let's run the program. And you can see the creating new file is printed onto the screen. So similarly, we can have another function called as save. So save function is going to return nothing to the user, so we will call as, let's make it something interesting. Let's say save function returns the boolean value, and it is going to have a name called as save, and it is going to receive some kind of file name that we want to have. So in order to receive a string value, we have two ways for that. One is using a pointer, and one is using a data type that is provided to us by C++. So if you want to receive any string a string type of input to any function, then we would simply type std : string, and then the name of the variable that we want to use for that value. So in our case, I want to call it as file name. So file name will be a type of string. So now I want to print it onto the screen. So let's say cout saving file and then the name of the file. So I will put another stream insertion operator and then I will call it as file name. And then to print a new line at the end, I will put a \n. So this is going to be our save function. And remember that we mark the function as bool, so it should return some kind of boolean value. Boolean values are simply just true or false. So we need to return some kind of value. Let's say our save was successful, so we return the value as true. Now we want to create some another function called as export. Now export is also a reserved keyword in C++. So we will first of all define the data type that our function is going to return. It is not going to return anything. So we say void and then we name the function called as file underscore export. And the file underscore export is going to take the type of file that we want to export. Let's say file export will export the file as HTML or PDF or some kind of Word document or some kind of Excel document, Excel style sheet, Excel workbook, or any other type of file that you can imagine. So we need to take a string inside of it and we need to call it as type of file. So variable names could have underscores in them. That is totally valid. So I want to print exporting file as type and then the name of the file, type of file. Okay, now I want to show you another way to put a new line at the end. So this std colon colon and l simply means that it should be a \n should be placed at the end. These both are totally equivalent in our case, so I just showed you another way to put a new line at the end of a string. So a function is not going to return anything. So that's all for the export function. Now we are going to have similarly a kind of exit function. Okay, so exit function is going to return integer value and it is for now it is going to return, let's say 0. This is all our exit function is going to do. So exit function will close the program and then it will return the value called as 0. Let's print the text. Let's put as, let's in this case let's use put as exiting the program. So that is, let's see what other functions we have left. We implemented the new file. We are left with to implement open file function. So we can have void open. And let's say it also returns some kind of integer value or boolean value. If the file is successfully opened, it is going to return true, else it is going to return false. So it is going to take a file name, okay, as an input, and then it is going to print std colon colon cout, and then it is going to print opening file with name file name, okay, and then we are just going to return true in our case. Okay, so any positive value that you return from the open or any other function will be treated as true in our case. Let's say if I return the value 10 as in this case, so this 10 is totally valid and it is going to be equivalent to true. Okay, so for false you just have only one value. If you return anything as 0, then it is assumed as false. So we are going to return true, our file opening was successful. So that is all how to implement simply all these tasks of a text editor, that is opening a new file, saving a file, exporting a file, exiting the text editor, opening another file. let's say, okay, opening a file, and then we are calling the Windows functions. Okay, so let's say I want to create a new file, then I want to open a file. I want to pass the open function, and the file, it will require you to pass the file name. So file name is going to be intro.cpp. In our case, we want to open that file, and then we want to export the file as, let's say I want to export it as a txt file, text document. Okay, so file underscore export, and then I'm going to specify the type of the file that I want to export to. So I'm going to export it as txt. So then I want to exit the program. So I will call the exit function, and that's all our text editor is going to do for now. And I think we left some function. Save, we left the save function. We can call the save function. Let's call the save function. And the save function, does it take some arguments? Yes, it takes file name. So we pass it as copy.txt. Okay. So we passed the copy.txt as the file name to the save function. It is going to save the file. Now let's go ahead and compile and run the program. Now let's say G++ and then the name of the file we want to compile. And I want to show you a little bit of shortcut to prevent every time writing this compilation and then executing statement again and again. We can write both of those statements in one line. So I will put a double and in this case, and this statement is valid on Linux as well as on Windows. So we will put a double and, then the second statement that we want to execute after the first program is over. So we want to call the a.exe, because the intro.cpp file is the compiler is going to compile the file and save it as a.exe, and then we will execute that file immediately after that. So I press the enter key, and you can see we got the creating a new file, saving the file, opening the file, and then exiting the program. And we also saw this exporting file as type txt. So there was one issue with the program, that is, the exporting the file as txt was printed on the same line as opening the file with the name intro.cpp. So let's check the opening function first of all. You can see we are not printing a new line at the end of this function. So let's put the std : and l, and let's compile and run the program once again. And this time we will see that new line is totally added after that, and we see exporting the file as type txt on the next line. Now let's proceed further. So functions are just some type of tasks. Function represents some kind of tasks. They are a group of statements which are provided some kind of a label, and this is the syntax of the function, which is you specify the return value, name of the function, arguments, and we coded the text editor. Now I want to clarify one most common question in the programming world, that is, should main return void or it should return integer type values. So in our case, we said that main function is going to return of type as type integer. So I can also mark the main function as void and totally get rid of this return statement. That is totally valid for C++ or for C++ compiler at least. So let's say if we compile the program and we see that main must return integer. So the C++ complains us that the main function should return as integral values. So why is that the case? So I want to clarify this thing, why the main function should return integer values. For that, we need to understand how the operating system works. So whenever our program runs, the operating system allocates some memory to the program. The program uses resources offered by the operating system. For example, using a C++ program, we can write the file to the hard disk. We can just open a file from the hard disk. We can change the contents of the memory, we can do a lot of other steps. We can utilize the CPU to do some kind of calculations for us. So we ultimately end up using the resources which are offered by the operating system. So program notify whenever the program exits, then it notifies to the operating system that it has completed its tasks and it no longer needs the operating system or hardware resources. So in order to signal the operating system that my execution is complete, I just want to free the resources. The program returns some kind of integral value to the operating system. And whenever the program on exit returns some kind of exit value, the operating system knows that the program exited. Now I can just go ahead and free the memory. I can go ahead and take the hard disk resource back from the program. I can just clear the RAM which was provided to the program, and I can do a lot of other stuff. This helps the operating system to free the resources. So there is the memory portion that gets created into the RAM whenever a program is run. Onto the right side, we have the program memory that is allocated by the operating system, and onto the left side, we have the operating system modules that our program can use. So on the right side, I will be discussing on the right side first of all. So on the top, we have OS modules. Operating system modules are just the written libraries or written code which helps us communicate with the hardware. So we have file management module which helps us manage the files, reading the file, writing to a file, navigating to a file, finding some text from or to a file. That is all the task of file management module which operating system offers to us. Then we have system calls. System calls helps us execute the commands that operating system on behalf of the operating system. Okay, so in our case we executed the command pause command. Okay, so we executed the pause command using that system and then invoking that system function. That is the example of a system call. Then we have hardware drivers. Hardware drivers is the, and you can think of it as the second layer below the operating system modules. The hardware drivers are just the softwares which tells operating system how to communicate with the hardware, how to access the hard disk, how to write data to the hard disk, and how to read data from the RAM, how to do multiple other tasks, or how to print some file to the printer or using a printer. That is all the task of hardware drivers. Then we have memory management and network devices. All this stuff is managed by the operating system. But below the operating system modules, we have a stack. So the stack is the portion of our own program. Whenever we call some other function, so let's say we call the function called as new underscore file from the main function. The new underscore file function first of all gets created into this stack. So the entire function is going to be copied into the stack, and then operating system is going to look that new file function is this. It is copied into the stack. What are the different tasks that I need to do? So in this case, it needs to send some task onto the. It needs to send some string to the screen. So first of all, it creates this text into the stack. So in some memory is allocated to the string, creating a new file. It is stored inside of the stack memory, and then after it is created over there, it is going to be sent to the output screen. And then the function exits itself. Then the stack gets another call of the save function. Similarly, the save function is created inside of the stack, and now it holds a variable called as file name. So the file name is only accessible in that save area of the stack. Okay, so we can simply access the file name from over here. So that is the use of stack just keeps record of our program, which functions are executing right now, what are the variables which I need to create now, and all that stuff is kept track of by the stack. Then below the stack we have a heap portion of the memory. Heap portion of the memory is a little bit more permanent than the stack. So heap portion of the memory remains longer than that of the stack. Now let's say I create a new file and I call this new file function from my main function. So it gets created inside of the stack. It does print the creating new file onto the output screen, and then it exits itself. So now the question is this new file function still present in the stack? And the answer is no. Whenever the function exits itself, it is removed from the stack. So the memory of new file function is released whenever it completes its execution. That is the main task of the stack. Whereas in case of heap, the variable is still kept into the memory even when the even when the function exits itself. The variable is deleted from the memory only when the program exits itself. So whenever the main function over here executes itself, completes its execution, and it returns something, then only the heap memory will be cleared by the operating system. So heap is the last memory that will be cleared by the operating system. Okay. Then below the heap we have global variables. Global variables are some type of data values that exist in the whole scope of the program. So let's say I want to create a new variable that all of my functions can access. Let's say I create a value called as integer and I call as is let's is registered equals true, and I need to change it to boolean. Okay. So I want to store a value called as is registered inside of the RAM, and I want to use this is registered in all of my functions. If so, let's say if user has paid some money to me for buying this software, then only I want him to use all these functions. Let's say new file, save, file export, exit, and open, and every other function inside of my program. So I can use that easily. So for now, let's just go ahead and print that value onto the screen to see can we access it inside of any function. So let's say std colon colon cout, and then let's say is registered. Okay, std colon colon and l at the end. And now let's change this void to be integer, and let's change it to be return 0. Let's go ahead and compile the program, clear the screen first of all. So we can see that we got 1 as the value. So 1 is the, because we have marked it as true, true just simply means 1. So we can access this value anywhere inside of a program. So if I need to print it over here is registered, I can simply do that. Now let's say I execute the program, and you can see 2 times 1 is printed. So that is because the 1 is also printed from inside of the new file. Okay, so now I can get rid of this statement, and this printing of is registered. So these are the global variables which any function can execute or access in our case. Next we have environment variables. These are some special type of variables that are only created whenever the program runs itself. It creates some kind of variables to keep track of information about it, in which environment it is running. Let's say you want to have some kind of secret key to unlock your program, then you can store that inside of environment variables. So it will be available till the program exits itself, and it will be created when the program starts. So that is the use of environment variables. Next we have a text section at the bottom. So the text section contains the binaries of whole program. So binary simply means zeros and ones. So our program is compiled into zeros and ones, and then the zeros and ones are stored inside of this text section of the memory. And now the question is, you want to free the resource, and OS tries to free them whenever your program exits itself. So let's say some kind of error occurs in your program and your program is reading from a file. So the operating system needs to do some additional cleanup in that case. So additional cleanup would be closing that file or saving data to the file or not letting you the file to get affected, okay, preventing the file to be affected. So now how do I know that this some kind of error is occurred or not? In order for that, operating system allows me the ability to check whether the program exited successfully or is it exited with some errors, or does the operating system do some kind of cleanup, or it just did it, or it just continued it execution, okay. So inside of the command prompt, we can execute a command called as echo and then a percentage symbol error level and then again a percentage symbol. So this is the command that tells me whenever the last program ran, what was its exit status. So was the program exited successfully or was some kind of error occurred during the execution of the program. So in my case, I get the value as 0. So 0 simply means that the program exited successfully. There was no error when the program exited. So now let's go ahead and change this value from 0 to let's say 10 or any other random value that you can imagine. And let's run the program once again. Let's do a.exe and now the program runs successfully. And now let's print that error level again. So in our case, we got the value again as 0. So that was because we did not compile the program. So we need to again compile the program because we have changed some line of statement and we haven't compiled the program. Let's say I compile the program as intro.cpp and then and double and then let's say a.exe. Now the program runs exit itself. Let's print the error level and this time I get the value as 10. So this error level is the variable in which operating system keeps tracks of your program. Was your program exited successfully or was it exited with some kind of error? So that is the reason why our main function should always return the integral values because it notifies the program that your program exited successfully, it freed all the resources, and now operating system does not need to do any additional cleanup in this case. But if the program exits with some kind of error, the operating system will perform some additional cleanup, such as freeing the memory that your program acquired during the execution, or freeing the resources, or taking back the resources from your program that your program used. That is all the additional cleanup in this case. So now let's continue further and let's talk about the namespaces. So let's get started with what namespaces can do for us and what namespaces are. So namespaces are usually much bigger container than the functions. So they are also some kind of containers. The namespaces can include multiple functions inside of them. They can include multiple classes, structures, preprocessors, and a lot more stuff inside of them. So a namespaces could contain multiple functions inside of it and multiple variables, and then it can provide a single name to all those stuff. And this helps us organize our program. Now let's see the demo of this namespaces so that we can understand it a little bit better. So namespaces are usually created using the namespace keyword and then the name of the namespace we want to provide. So let's say I want to provide a namespace called as editor because I want to use all these, I want to say that all these functions belongs to editor class. So I can just go ahead and cut all of them and I can paste them between this opening and closing braces of the namespace. So let's go ahead and paste them over here. So now namespaces editor contains all these functions, and if you see over here you are going to get some kind of error. Now you cannot execute the new underscore file function directly. You need to specify in which namespace is this function present. For example, you can do something like this. You can call the editor, then double colons to access the members of the namespace. So this is double colons is called as scope operator. The scope operator helps you access the member of some kind of some namespace. In our case, we created a namespace called as editor, so we can access the members of the editor. Editor has a functionality to create new file. Similarly, we can create an editor colon save to call the save method inside of the editor save function, editor open to call the open function, and then similarly we can have editor file underscore export, and similarly we can have std exit. So this is how we can access the members of the namespace. And now I want to talk you a little bit more about the usage of these namespaces. For now, we have always been doing something like this std c out, and then we print something onto the screen by passing the string into the c out stream. Okay, so this c out is some kind of feature that is present inside of the std namespace. So this std namespace is created by the C++ developers for us. So std stands for standard. So this is the standard namespace and it contains a lot of other functions that are offered by C++. In fact, you will find most of the functions offered by C++ are present inside this std namespace. So now there is another way. I made a mistake over there. I just wrote it as std and I told you that it should be editor. So there is another way to access the namespace. How we can do that? You can use the statement code as using namespace and then the name of the namespace that you want to use. So you can use editor. So in this case, I can get rid of this editor statement and I can just simply call this save and any other method that I want to call. So this is how there are two ways to use the namespaces. So using namespace editor is one way in which you declare the using namespace and then the name of the namespace at the top and then just simply execute these functions. And another way is to prefix the name of the namespace before the function. So this is editor new file. So you can do any of that, and this is how you can group multiple functions inside of a single name. So in my case, all these functions belongs to the editor namespace. So that is how you can create the function namespaces, how namespaces works, and how you can use the namespaces. Okay. Now I want to talk about preprocessors. So whenever the our program is compiled or the executable file is generated, it involves several steps. The first step is preprocessor. A preprocessor is just simply copying the contents that is specified after the hash include keyword, and it is going to be copied into the file that needs to be compiled. So in our case, we included IO stream at the top. So whatever the IO stream file contains the operating system, or not the operating system, the compiler is going to search for this iostream file on the hard disk, and it is going to read this file, copy everything from that iostream file, whatever is there present inside of that file, and it is going to just paste that content over here. So it is going to paste content here. Everything from the iostream file will be pasted over here. This is the use of preprocessors. This is only what preprocessors does. That is the only one task. Then we have another step, that is compiler. Compiler checks for errors in the code, and if there is no errors, then it generates the assembly code from that high level language code. So it converts all these boolean, save, std, strings, file name, all these C++ instructions into assembly language. Assembly language is much lower than the C++ language. Then we have the assembler. Assembler generates the object code of the program, which is near about zeros and ones. So object code is zeros and ones. Then we have linker. Linker get the required dependencies and link them to the program. So let's say we require, our program is dependent on this cout over here. Cout is the dependency of a program. So linker is going to take the code for this cout statement, and it is going to add that code into our program, so our program can use it anytime it get executed. So then at last we have executable file, which is just the stored form of binaries, which is just zeros and ones are stored into a file, and it is called as executable file. That is all executable file is about. Now I want to refactor this text editor to use preprocessors, or to take the help of preprocessors, and this is going to clean up our main file. So let's say I have a new file called as editor.cpp. So inside of editor.cpp, I want to somehow get all this code. I'm going to I'm going to cut and paste the code of this namespace, and I'm going to paste it inside of editor.cpp. Now editor.cpp also need access to this cout and cin. Cout first of all only. So let's include iostream, and let's save it. Now the editors.cpp file is just fine, and we need some way to use this editor.cpp file inside of our main program. So I told you that preprocessor does it only one task. It copies all the contents of that file and paste it into this main source file, which is intro.cpp in our case. So I can include a statement called as hash include, and then instead of using those angle brackets, I can use the double quotes, and then I can specify the name of the file. So in my case, it is editor.cpp. So edit contents of the editor.cpp file will be copied into my intro.cpp file whenever my program is compiled. So now let's get and let's test it out. So we can compile and run the program, and I see that we got a warning that is extra token set ahead of hash include directive. So usually hash statement does not need to end with a semicolon, and that's only a warning, so a program compiled and ran successfully. So using with the help of preprocessors, we are able to refactor our code and separate it into multiple files, so that our code becomes reusable and it becomes maintainable. So we can maintain our code, we can keep our code clean. Okay. So this was with the help of preprocessors. Now there is one difference in using the preprocessors. We have this angle brackets syntax, and then this double brackets or this double quote syntax. Okay. So what is the difference between them? The first difference is that angle bracket search for file in directories specific to compiler. So the compilers already set some directories that it should look for in the file inside of our hard disk. Okay, and the double quotes syntax is going to search for file in current directory, and if not found, if it does not find the file in current directory, then it is going to search for in compiler specific directories. Okay, so this is the main difference between these angle brackets and these double quotes. It is just searching this file editor.cpp where we want to search it. So in my case, I want to search it into the current directory, so I use the double quotes. Whereas IOStream is present inside of the compiler specific directory which the compiler set, and I wanted to search on in those directories, so I specified these angle brackets. Now I want to show you that this IOStream file actually exists on your hard disk. So whenever you install the compiler on your hard disk, you install it somewhere onto the program files. Let's see. Okay, in my case it is program file x86, dev cpp, and then min.gw64. This is the name of the compiler that I installed. And if I go ahead and search over here in all these directories, let's say I search for IOStream, and you can see the IOStream file is present onto the hard disk. And where is it? Let's go properties, let's copy the location of the file, and let's paste it over onto the top. So this is the location of the file, which is inside of min.gw. We have a library folder, then we have gcc, and then again we have x86 underscore 64 dash w64 min.gw32 4.9.2 include C++. So inside of this directory we have the IOStream file. So we have this IOStream file. Okay, this is simply a text file. It does not contain much information about this include and output functions. Let's say if I open it inside of this Visual Studio Code, then you can see on the top we have the comments. This is the comment section on the top, and it says this is the standard C++ library header. And then we have some statements such as hash if not defined this, then define this. So if this variable is not defined, then you need to define this variable, and you need to assign it a value of 1. So wherever you use underscore glibcxx underscore iostream, that should be replaced with the value of 1 at the runtime. This true statement simply means this, that replace the underscore glibcxx with the value of 1. Okay, then we have pragma specifier. This is dependent. Pragma is usually for Windows. It is not, it is platform specific. The pragma is actually platform specific, so you will find different commands for Linux in this case and different for Windows. So pragma values can vary from operating system to operating system. And then we include similarly bit slash c++ config.h, and then ostream, then istream. Okay, so the ostream file again contains those cout scene functions inside of it, and we can see that we got a beautiful line number 42, which is namespace std, and then we have some text over here which we do not understand yet, and then inside of that namespace we have few stuff. So that we think that the developers of the C++ has created this namespace, and this namespace contains this, you can see external ostream cout. So this contains some kind of linked to standard output, that is some type of standard output screen. So we can send some messages to the output screen. So this cout is just a statement which links the output screen to a main program. So you can use that output screen through the your C++ code. Okay, so that is all this IOStream file contains. And this IOStream file, all these are simply called as header files. So they will only contain the declarations. They will never contain actual implementation. Actual implementation is always preferred to be written inside of .cpp files, and these are just simply the text files that help you know what is the functionality that is present inside of this IOStream library. So we can use the cin, cout, cerr, clog, all these streams or all these output buffers. Okay, so that is all this preprocessor does. Now let's continue and let's talk about the summary of this video. So we talked about functions. Functions help us to implement tasks by grouping statements in a container. And then we saw that functions are stored in stack during execution of the program. Main function must return an integer value. And then we have the void is used when we do not want to return any value from the function. And we have functions should be implemented to complete one task at a time. That simply means we should not do multiple tasks inside of one function. That is, if you want to open a file, you want to close a file, you want to write to the file, you want to update a file, that should be done via different functions. Saving should be done by a different function, opening should be done by a different function. You should not create one function that is called as do editor task and then write a bunch of statements inside of that single function. That should be prevented because it makes your code unmaintainable. Then we saw about namespaces. Namespaces allows us to group various functions in the same name. Namespaces are mostly used in developing libraries or modular software. Modular software simply means that you can separate your software into multiple files and then you can include all those files, and you can write the software in form of modules. For example, you can have a file module which just has all the functionality that the file menu should offer, and you can simply have edit module, another edit module, view module, all that stuff. Okay. Namespaces could contain functions, global variables, or any other valid C++ statement. And then we talked about preprocessors. Preprocessors are used to separate our program in multiple files. Preprocessors are commonly used with header files. And as we saw in the IO stream, that it in fact includes those header files. And we will talk about these header files later in this series of videos. For now, for this first video, that's it, and that's all. So I will see you in next video. Okay.